Hello, today we're going to be solving 1.4 literal equations. So a literal equation is an equation where variables represent known values. So an equation where variables represent known values. So you're going to have a lot of different variables in these equations, and they can be formulas or they can just be variables. Um, and we're going to be solving for any given variable in that equation. And the goal for solving any equation is to get a certain variable by itself. So get a certain variable by itself. And so what's going to happen is you're going to be given an equation and you're going to be told solve for A or solve for B or solve for C depending on the equation. So examples of literal equations are some formulas that you have seen before. So perimeters and areas and Fahrenheit to Celsius. So in any given one of these, we're going to pick a variable, for instance, B here, and we'll say get B by itself. We'll solve for B. So in order to do that, what we're going to do is we're going to start with things that we know and then move to the literal equation. So looking at example 1a, if I were to say, hey, solve for x, you'd look at that and say, oh, I need to move the 5 to the other side. I'd get 3x equals 3. I would then divide by 3 and get x equals 1. You get a number that you can go back and you can check by plugging it in and seeing, yes, 1 works. For a literal equation, we're going to have the same type of setup. So notice it's in the same format, but this one has ax plus b equals c and no numbers. So the first thing is figuring out what you're solving for. We are solving for x. So we want to get this x by itself. And so to undo the things near it, you can kind of imagine what did we do over here to get that x by itself? And so what we did is we moved the adding and subtracting over first. So we're going to go ahead and we're going to move this b over by doing the inverse operation and subtract it over. So the tricky part here is now we get ax equals, and now we have to write out c minus b. Because we don't know what c and b are, we don't get an actual number there. We just write them both down. Then, after we moved the linear term over or the constant over, we're going to go ahead and get that coefficient gone. We're going to get rid of the a, and the a is right now connected by multiplication. So to undo that, we're going to go ahead and divide it to the other side. And we can't actually divide these, they don't reduce. So we're just going to write c minus b all divided by a. So now we have x all by itself. We have x equals something. That is our solution. We can't solve it anymore, so we just leave it like that. So let's try another one. So first we're going to try it with the regular equation, and then we're going to go ahead and try the literal equation. So for this first one here, we want to get x by itself. So we're going to subtract 10 from both sides, and then we would divide by -2. So we would get x equals 3/2 because a negative divided by a negative is a positive. So it's the same idea for the next one. We want to get x by itself. It says solve for x. So we need to move the m and the p to the other side. Just like in part A over here where we moved 10 over first, we're going to move the m over first. So we're going to subtract m from both sides. We get -p times x equals, and we're just going to have to write n minus m. So then what we're going to do is we're going to divide by -p, and we're going to get x equals n minus m over -p. So even though there's no numbers in this one, we can still get x by itself, and our answer is going to look a little bit interesting like that and not a nice, solid numerical answer. So that's the idea. So now what we're going to do is we're going to start solving ones that are just the literal equation with none of the other algebraic stuff with it. So for this one, we want to solve for a. We got to get a by itself. So what we're going to do is we're going to move the c to the other side because adding and subtracting is the weaker link, so we move that over first. So b plus c, I can't actually add them together because I don't know what they are. Now looking at this, again, my goal is to get a by itself. So I'm going to get rid of that 1/3. I'm going to go ahead and multiply both sides by 3. And as I do that, on the left-hand side, the 3 and the 1/3 undo each other. So I'm just left with ax. On the right-hand side, when I multiply by 3, I have to multiply everything by 3. So it's 3b and 3c. And then I'm going to go ahead and, oh, nope, I don't want to divide by a. See, careful with that. I just didn't. I want to get a by itself. I'm going to get rid of the x instead. So I'm going to divide both sides by x, and I get a equals 3b plus 3c, all divided by x. So next one here, we want to get x by itself. So I'm going to move the d to the other side. It's right now being added, so I'm going to subtract it over. I get x over b equals c minus d. Then right now x is being divided by b, so I want to get rid of that b. I'm going to go ahead and multiply both sides by b. And here's another case where I need to go ahead and put parentheses and multiply everything over here by b. So I'm going to write bc minus bd. So x equals bc minus bd. And if you wrote it as cb minus db, that's fine too. It's the same thing. You might see this written out differently, so make y a function of x. That means take and solve for y. You'll see these types of equations later this year. This is standard form and point slope form. So we are going to need to be able to take these and solve for y. So notice there are some numbers in this one. So right now what we're going to do is we're going to move the 2x to the other side. We get 4y equals negative 2x plus 16. Right now, again, I'm trying to get y by itself, so I'm going to divide by 4. And I am going to divide each term by 4. So this first one, negative 2 divided by 4, becomes negative 1/2. So that's negative 1/2 x, and then plus 16 divided by 4 is 4. So we get y equals negative 1/2 x plus 4. For the next one, to solve for y, I see parentheses there, so I'm going to take care of that first. I'm going to go ahead and distribute those parentheses, so I get 2/3 x minus, and here I'm going to show a little bit of work off to the side. 2/3 times 6, you're going to do 2 times 6 and get 12. You're going to do 3 times 1 and get 3. So multiply the numerators, multiply the denominators, and then 12 divided by 3 is 4. So now y is almost by itself. Right now it's y minus 3. So we're going to get rid of the minus 3 by adding 3 to both sides. So we get y equals 2/3 x minus 1. That would be y as a function of x. Now, these last two, go ahead and try pausing the video and solving for the variable indicated, and then come back and listen to the explanation afterwards, so after you've tried it once. So for this one, we're going to solve for h. So we need to get everything else to the other side. And so what I'm going to do right now is I'm going to get rid of that fraction because a lot of times we don't like seeing that. So we're going to multiply by 3 on both sides to undo that 1/3. So we have pi r squared h all there on the right-hand side and 3v on the left-hand side. Now, if we're trying to solve for h, right now we have pi r squared all together there. Pi r squared is being multiplied by h. So to undo it, we're going to go ahead and divide by pi r squared. And so it's going to cancel out or undo. On the right-hand side, you get h. On the left side, you get 3v divided by pi r squared. And that's the best we can do. We can't really write it as anything else. We're just going to leave it like that. The next one, we have this b1 there. There are many different ways you can solve this. So you can distribute, you can multiply and get rid of fractions. So the way I'm going to do it right now is I'm going to get rid of this 1/2 first and multiply both sides by 2. So the 2 and the 1/2 cancel out. I get 2a equals B1 plus B2 times H. Now you can either distribute the H to everything, or you can go ahead and divide both sides by H. And so you get 2A over H equals B1 plus B2. And now what I'm going to do is I'm going to move that B2 to the other side, because again, my goal right now is to get B1 by itself. So I'm going to move the B2 over by subtracting. So I get B1 equals 2A over H minus B2. Now, depending on if you had solved it differently, you might have gotten B1 equals 2A minus HB2 over H. You might have gotten this as an answer because you solved it slightly differently, and that's okay. If you have something like this, you can rewrite each part of this numerator divided by H, and if you simplify it, it ends up being the same answer that we got. So just because you get a different answer doesn't mean you're wrong. It's just maybe you did it a different way, and so it didn't look exactly the same as mine, and that's okay. Okay, so thank you very much for listening.